In the class we are going to discuss few more important problems. This problem is based on the properties of analytic function. Write the problem. Sometimes it comes. This is very important problem. If f of z equal to u plus iv is an analytic function, if f of z equal to u plus iv is an analytic function of z, show that dou square by dou x square plus dou square by dou y square mod f of z whole square equal to 4 f dash of z whole square. It is an important problem. Write the solution for this. So what is the question here? F of z equal to u plus iv is an analytic function. Given f of z equal to u plus iv is an analytic. If f of z equal to u plus iv is an analytic, of course we know that it satisfies CR equations. It satisfies CR equations. That is ux equal to vy and uy equal to minus vx. Okay, na? Now, listen, f of z equal to u plus iv. What is mod f of z? Mod f of z equal to square root of u square plus v square. Mod f of z equal to square root of u square plus v square. So what is f of z whole square? Mod f of z whole square equal to u square plus v square. Taking some phi of x comma y, write in the bracket, say we are defining one function phi of x comma y. That phi of x comma y is that f of z whole square, that is u square plus v square. You take it this as equation number 1. Okay, fine. Differentiate 1 with respect to x. Differentiate 1 with respect to x. That means phi of x comma y equal to u square plus v square. You are differentiating with respect to x. So what you get? Dou pi by dou x, which is equal to 2u dou u by dou x plus 2v dou v by dou x. Have you done the problem? No, no? Okay, fine. So differentiate again with respect to x. Differentiate again with respect to x. If you are differentiate again with respect to x, then what you get? Dou square pi by dou x square equal to 2, take it outside. So here 1 2 is there, 2 is there. Take it outside. Then keep it u. Differentiation of dou u by dou x is dou square u by dou x square plus keep it dou u by dou x, and then differentiation of u with respect to x is dou u by dou x. So dou u by dou x into dou u by dou x is dou u by dou x whole square. Similarly, keep it v. Then differentiation of dou u by dou x is dou square v by dou x square plus, then write the dou v by dou x. Differentiation of v with respect to x is so dou v by dou x whole square. Is it not? This is equation number 2. This is equation number 2. Similarly, differentiate 1 with respect to y. Similarly, differentiate 1 with respect to y. Then what you get? No, first dou pi by dou y, na? Dou pi by dou y equal to 2u dou u by dou y plus 2v dou v by dou y. Now, differentiate again with respect to y. Differentiate again with respect to y. Now what you get? Dou square pi by dou y square equal to dou square pi by dou y square equal to 2, keep it outside. Then u dou square u by dou y square plus dou u by dou y whole square plus v dou square v by dou y square plus dou v by dou y whole square. It is equation number 3. Adding 2 and 3, adding 2 and 3. If you are adding 2 and 3, you will get that dou square pi by dou x square plus dou square pi by dou y square equal to, keep it 2 outside. Then here u common, take it u common, dou square u by dou x square plus dou square u by dou y square plus, take it v common, then dou square u by dou y square, sorry, dou square v by dou y square, dou square v by dou x square, na? Okay, fine. Plus here dou u by dou x whole square, dou v by dou x whole square, then 2 times dou u by dou x whole square, dou u by dou y whole square, dou v by dou x whole square, dou v by dou y whole square. Okay, write down. Plus dou u by dou x whole square, dou u by dou y whole square plus dou v by dou x whole square plus dou v by dou y whole square. Close the bracket. Since it is the analytic function, it satisfies harmonic equation, Laplace equation. Write down. Since it is analytic function, u and v satisfies Laplace equation. U and V satisfies Laplace equation. So what is Laplace equation? What is Laplace equation? Dou square u by dou x square plus, that is, write down, dou square u by dou x square plus dou square u by dou y square equal to 0. Similarly, dou square u by, dou square v by dou x square plus dou square v by dou y square equal to 0. And by CR equation, ux equal to vy and uy equal to minus vx. So therefore, what happened is, you can see that this is 0. This is 0. Okay. So the dou square u by dou x square, dou square u by dou y square equal to 0. Dou square v by dou y square, dou square v by dou x square 0. The two things are 0. Remaining everything you have to change in terms of u. So what you get? Listen. So finally you will get that dou u by dou x whole square. Therefore, adding 1 and 2 we will get. What is adding 1 by 2? 1 and 2, dou square pi by dou x square. Dou square pi by dou x square plus dou square pi by dou y square, which is equal to, now listen, 2 into dou u by dou x whole square plus dou u by dou y can be written as, dou u by dou y can be written as minus dou v by dou x. That minus can be squaring now. If you are squaring, it will be plus. So dou u by dou y, dou u by dou y na, dou v by dou x, dou v by dou x whole square plus, once again, dou v by dou x whole square. Here dou v by dou y is there na, that can be written as dou u by dou x whole square. So finally we will get that 2 into 2 times of dou u by dou x whole square plus 2 times of dou v by dou x whole square. Let f of z equal to u plus iv. That implies f dash of z equal to dou u by dou x plus I dou v by dou x. Mod f dash of z equal to, square root of dou u by dou x whole square plus dou v by dou x whole square. Now, what is mod f dash of z whole square? F dash of z whole square equal to, dou u by dou x whole square plus dou v by dou x whole square. Now see that here, taking 2 outside, this equation is then equation number 4. It is equation number 4. Equation number 4 becomes, how can we write that equation 4 becomes dou square pi by dou x square plus dou square pi by dou y square equal to, already 2 is there, taking 2 outside, 4 times of dou e by dou x whole square, dou v by dou x whole square. That dou e by dou x whole square, dou v by dou x whole square is mod f dash of z whole square. So therefore finally we can write that, take it that pi outside, here dou square by dou x square plus dou square by dou y square pi equal to 4 f dash of z whole square. But what is pi here? What is pi? In the beginning we have taken pi equal to f of z whole square. So pi equal to f of z whole square. Once again substitute this, pi equal to f of z whole square. Then we will get that dou square by dou x square plus dou square by dou y square mod f of z whole square equal to 4 f dash of z whole square. Hence proved. Wait for 1 minute. If anybody is waiting there, then we can. Oh, it came outside. Network problem maybe. I don't. Okay, I need to share now. Sharing also not working maybe. So and then we have discussed one important topic, Milne-Thomson method. We have done two problems based on that Milne-Thomson method. We have done two problems in Milne-Thomson method. Is it not? U equal to x cube minus 3xy square plus 3x square minus 3y square. One problem. One more problem is, second problem, find an analytic function w equal to u plus iv if u equal to e power x, x sin y plus y cos y. Two problems we have done based on this. In that Milne-Thomson method, one or two problems we can do. Already I sent that PDF to you. Okay, so no need to write this. Already I sent that PDF to you. No need to write this. Just listen. That is enough. So here, how to find that? How to construct the analytic function? In case if it is that some different form is given. One example I can write here. One important problem. This type of problem also will come. Do you know now what is harmonic conjugate? What is mean by harmonic conjugate? V is the harmonic conjugate of U. U is the harmonic conjugate of V. Okay. So the problem may come based on this harmonic conjugate, and construct the analytic function. See that example. Find the analytic function. Find the analytic function. Find the analytic function. F of z equal to u plus iv if u minus v equal to sin 2x divided by sin 2x divided by cos h2y minus cos 2x. Find the analytic function f of z equal to u plus iv if u minus v equal to, listen, in the last class we have seen that u is given or v is given. Here u minus v is given. At the time how can we do? U minus v is given. At the time how can we do? Now listen, write down, write the solution for this. Let f of z equal to u plus iv. Then I into f of z equal to multiple with the I on both sides. We will get that I into f of z equal to iu minus v. Okay. Then if you are adding these two, f of z plus I into f of z equal to u minus v plus I into u plus v. That means 1 plus I into f of z equal to u minus v plus I into u plus v. But we need only that f of z. Na? We need only the f of z. So therefore what can we do is the 1 plus I f of z can be taken as capital F of z. Then this can be written as capital U plus I capital V. F of z equal to u plus iv. So here u is a real part and then v is a imaginary part of that capital F of z. We know the Milne-Thomson method for if small f of z is there. So what is the small, if small f of z, sorry, small f of z u plus iv is there, it is the function. Then how can you construct this? In case only real part is given, what is the procedure, you know? Only the real part is given. What is the procedure for construct the analytic function? I have given two cases. One is only real part is given. Second one is only imaginary part is given. If the real part is given, then we have to write that differentiate with respect to x. That u is given. U is given. U with respect to x, we will get ux. With respect to y, we will get that uy. Then substitute x equal to z and y equal to 0 on both. Then we can find that analytic function. Is it not? Now differentiate u where u is what? Write down where capital U equal to, given that u minus v. Is it not? U minus v, which is equal to sin 2x divided by cos h2y minus cos 2x. Fine. Differentiate with respect to x. Differentiate capital U. You are not differentiating small u. You are differentiating capital U. Capital U with respect to x. Then we will get the dou u by dou x. So you have to write carefully capital U, small u. Okay. If small f of z is there, we can write that small u plus small iv. But here you have to write that capital U. But here capital U is what? In case when you have to write that capital U, capital V, when it is not single U and V is not given. They may be given U plus 2V or U plus V, U minus V or some imaginary part and real part, you have to write that. Then combination of real and imaginary part, na, if it is there, then you have to convert this into that capital F of Z equal to capital U plus I capital B. Okay, then we will do that one or two problem based on this. So what is dou E by dou X here? Dou E by dou X is cos H2Y, denominator cos H2Y minus cos 2X whole square. What is the numerator? What is in the numerator? Cos H2Y minus cos 2X. Then differentiation of sin 2X is 2 cos 2X minus, keep it that sin 2X. Then differentiation of cos H2Y is, sorry, not cos H2Y. Cos H2Y is 0 na. Only cos 2X is there. Minus already is there. Minus minus plus 2 sin 2X. So what you get here? Similarly, what is dou E by dou Y here? Dou capital U by dou Y. That is equal to, once again, denominator is cos H2Y minus cos 2X whole square. In the numerator, cos H2Y minus cos 2X. If you are differentiating, sin 2X with respect to Y is 0 minus, keep it that sin 2X and then 2 sin H2Y. So therefore, what is Ux of Z comma 0? Dou U by dou X at the value of Z comma 0. That means substituting X equal to Z, Y equal to 0. Okay, listen. So here, once again it cut. I don't know. Yeah, it's there. Fine. Now listen. Dou E by dou X at Z equal to 0. Sorry, X equal to Z, Y equal to 0. Then what you get? 2 cos 2Z. 2 cos 2Z. And then here 2 sin 2x. Here also 2 sin 2x. X equal to Z na. 2 cos 2Z. 2 cos 2Z. 2 cos 2Z. Then cos H2Y. Cos H for 2 cos H2Y. No, inside the bracket. 2 cos 2Z. 2 cos H2Y. Yeah, cos H2Y is Y equal to 0 na. Isn't cos H2Y means e power 2y plus e power minus 2y divided by 2. So you will get that e power 0 plus e power 0 by 2. That means 1 minus cos 2z minus sin 2z, 2 sin square 2z, 2 sin square 2z divided by cos 2z whole square. That means minus is there, cos 2z whole square. Then simplify this. 2 cos 2 is z. 2 cos 2 is z minus 2 cos square 2 is z minus 2 sin square 2 is z divided by cos 2 is z whole square. But cos h2y is not, cos h2y is not 0 na, 1 na. 1 minus the 1 minus cos 2 is that here also 1 minus na, 1 minus cos 2 is that whole square. So what you get here? So 2 cos 2 is that minus 2, take it outside, cos square 2 is that plus sin square 2 is that 1. So 2 cos 2 is that minus 2 divided by 1 minus cos 2 is that whole square. In case if you are taking that 2 common, minus 2 common, 1 minus cos 2 is that divided by 1 minus cos 2 is that whole square. So here 1 cos 2 is that get cancelled. Then dou e by dou x at z comma 0, which is equal to minus 2 divided by 1 minus cos 2 is it. Similarly uy, dou e by dou y, dou e by dou y at z comma 0. Then what is dou e by dou y here? You can see, isn't dou e by dou y, first one is 0. If you are substituting x equal to 0, y equal to 0 means e power 2y minus e power minus 2y by 2. It is sin h2y, sin h2y. So if you are substituting y equal to 0, sin h2y equal to 0. Okay, leave it. So dou e by dou y at z equal to 0 is 0. Therefore, by Milne-Thomson method, if real part is given, what is, in case f of z equal to, write down, if f of z equal to u plus I v, then f dash of z equal to ux of z comma 0 minus I into uy of z comma 0, I into uy of z comma 0. Okay, so I have given two formulas. One is real part is given, what is a Milne-Thomson method formula. When that imaginary part is given, what is a Milne-Thomson method formula. Two formulas I have given. You have to remember two formula. Procedure for Milne-Thomson method, you have to remember. It is very, very important. When real part is given, this is the formula f dash of z. In case imaginary part is given, what is the formula? F dash of z Vx of z comma 0 plus I into Vy of z comma 0. In middle, plus will come if imaginary part is given. In case if imaginary part is given, in middle plus will come. If real part is given, in middle minus is there. Okay, so therefore you can write this as 1 minus cos 2z. 1 minus cos 2z can be written as minus 2 divided by 2 sin square z. The 2 get cancelled, minus cosecant square z, minus cosecant square z. Therefore f dash of z equal to f dash of z equal to this ux of z comma 0 minus I uy of z comma 0 equal to minus cosecant square z. Integrate on both sides. Integrate on both sides. We get integrate on both sides. We get f of z equal to cot z plus c minus cosecant square z. Integration is cot z. Cot z plus c. Now capital F of z. What is capital F of z here? But capital F of z equal to capital F of z equal to u plus iv 1 plus I into small f of z. 1 plus I into small f of z. So 1 plus I into small f of z equal to cot z plus c. But we need only that analytic function f of z, that is equal to cot z divided by 1 plus I plus c by 1 plus I is there, but it is a constant now. Therefore simply we can write that, no need to write that 1 plus I here. Therefore f of z equal to f of z equal to cot z by 1 plus I plus c. Okay, fine. One more problem in this example. I think this problem also I have given. Find the analytic function. Find the analytic function. Listen, if you are able to write, write that. Otherwise, no need to write. Just listen. This is very important problem. Find that analytic function. F of z equal to u plus iv. U plus iv if u plus v equal to x by x square plus y square and f of 1 equal to 1. So how to solve this? See, for both the problem you have to start with f of z. F of z equal to u plus iv. Then multiple with both side with I. I f of z equal to iu minus v. These two equations are there. If you are adding these two equations, adding 1 and 2. If you are adding 1 and 2, 1 plus I f of z 1 plus I f of z equal to u minus v plus I into u plus v. Once again you take that 1 plus I capital F of z equal small f of z equal to capital F of z capital U plus I capital V. But what is given here? What is given here? U plus V is given. But U plus V is that imaginary part of this capital F of z. Okay. So here U plus V, which is equal to capital V, which is equal to x divided by x square plus y square, x square plus y square. Now you can differentiate this with respect to x. Differentiate with respect to x and y. Then Vx equal to Vx equal to x square plus y square whole square in numerator y square, I think y square minus x square. No, no, y square minus x square, I think. Because yes, we are getting yes, y square minus x square divided by x square plus y square whole square. Now what is Vx at z comma 0 minus z square divided by z power 4. So that is equal to minus 1 by z square. Similarly, pi 2, that means differentiate with respect to y. Vy equal to x square plus y square whole square. Then in the numerator you will get that, I think, x square plus y square, differentiation of x is 0, minus keep it x 2y, that means minus 2xy divided by x square plus y square whole square. Therefore, Vy at z comma 0 equal to 0. Vy at z comma 0 equal to 0. Now, we have to write that formula by Milne-Thomson method. By Milne-Thomson method, if imaginary part is given, what is the Milne-Thomson formula for if imaginary part is given? Wait. F dash of z equal to, imaginary part is given, f dash of z equal to, write that formula, f dash of z, capital F dash of z equal to this formula. wait, u vy of z comma 0 plus I into vx of z comma 0. This is the formula. Capital F dash of z equal to vy of z comma 0 plus I vx of z comma 0. Okay, so therefore based on this formula we can get that capital F of z, capital F dash of z equal to what is vy of z comma 0 0 plus I vx of z comma 0 is minus 1 by z square, minus 1 by z square. Class minus 1 by z square plus c. Okay, so therefore if we are integrating on both sides, what you get? F of z, capital F of z equal to I into minus 1 by z square. The integration is 1 by z, but f dash of z plus c will not come now. Here only plus c will come. But what is capital F of z here? Capital F of z is 1 plus I into small f of z equal to I by z plus c. So okay, fine. So what is f of z? F of z equal to I divided by z into 1 plus I plus some constant c1. Okay, so given one more value they have given, f of 1 equal to 1. F of 1 equal to 1 means substituting z equal to 1 on both sides, you will get that f of 1 equal to, what do you get? F of 1, but here they have written different formula. I divided by z into 1 plus I They are multiple and divided with I think 1 minus I, 1 minus I. So f of 1 equal to what? I divided by 1 plus I. So if you are substituting plus C1 now, so f of 1 equal to 1, 1 equal to I divided by 1 plus I plus C1. Therefore C1 equal to 1 minus I divided by 1 plus I. So what do you get? 1 plus I minus I divided by 1 plus I. So 1 divided by 1 plus I is constant C1. Substituting here, f of z equal to I divided by z into 1 plus I plus 1 by 1 plus I. Okay, this is the analytic function f of z. Fine. Listen, what are the types of problems will come in that Milne-Thomson method? Last class we have discussed two problems. You can see that in the construction of analytic function, directly u and v will come, sorry, will be given. In the construction of analytic function, you can see that here u is given or v is given directly. U is given, v is given. Then how can you find that analytic function f of z? Otherwise, second one method is if u minus v or u plus v is given, then how can you construct the analytic function? There are two types of the problems are there. Okay. In the next class, we will see that tomorrow bilinear transformation and conformal method. Day after tomorrow. Okay. Thank you.